Hello, welcome back. This is a section over solving systems of equations by substitution or elimination. And what this is this is the algebraic method, okay? So this is the algebraic method. And I don't care which one you guys use. Some people like substitution better. Some people like elimination better. Okay, both of these are your algebraic method. All right, so substitution I tend to like more, but it depends on the equation that you're given. Sometimes you're given an equation that lends itself to use substitution much more easier than it does for elimination. So let's go ahead and take a look, and let's do some of these with substitution. Now I'm going to go ahead and just jump right in and show you how to do this using substitution. So what you have here is you have a system of equations. Again, what you're trying to do is you're trying to find where these two lines intersect. Okay, basically the idea, okay, your goal is to solve for x and for y. All right, and this is a pretty useful tool because it'll kind of come in handy much further down in your math career. Okay, so what I have here, both of these equations are solved for y. In this case, that both equations, y equals something and y equals something, I would use substitution. I would rarely ever use elimination on this. So what I do is I choose one of them. It doesn't really matter. But the idea is that I'm going to take the top one. Y is equal to negative 2x plus 3, okay, in this top equation. Now, this bottom equation also contains a y value. What I can do is I can rewrite my bottom equation using my top equation, okay? So what I'm going to do is I'm going to rewrite the bottom part over here. Now, I'm just going to do this part here. I'm going to do the equals 3x minus 2. And I want to write y. But I don't want to write y because I want to write what y is equal to. And y is equal to negative 2x plus 3. So what I do is I take negative 2x plus 3 and I substitute it in for y. I replace this y with what y is equal to in the other equation. So I'm going to write negative 2x plus 3. And so I have this equation now that's totally in terms of x. The only variable that I have is x, and I can go ahead and just solve for x. So what I'm going to do, I have a negative 2x on this side. I'm going to go ahead and add it to over here. So I'm going to add 2x to both sides. Add 2x to both sides. And so then what I get, negative 2x plus 2x cancels out. I end up getting 3 is equal to 3x plus 2x gives me a 5x, and then minus 2. Okay, and then I'm going to add 2 to both sides. Add 2 over here. And so this cancels out. I get 3 plus 2 on this left side, which is going to give me 5, and that's going to equal 5x. Okay, so 5 times some number x is going to give me 5. What's that number? Okay, that number is going to be 1, but algebraically, we can divide by 5 and divide by 5 here. This divides out to 1. So we get that x is equal to 5 divided by 5, which is also 1. So x is equal to 1. All right, and that's our value for x. Now what I do is I take this value and I have to resubstitute it back into one of these top equations. And guys, it doesn't matter which one you do, okay? I'm going to choose this one. So I'm going to take this value here of x equals 1, and I'm going to plug it into the x into either equation. It doesn't matter, but I'm just going to use the bottom one. So what I'm going to get is I'm going to get y is equal to 3 times x. But x, remember, is equal to 1. So I'm going to plug in 1 for that. So 1 and then minus 2. So I've got y is equal to 3 times 1, which is 3, minus 2. And so then y is equal to 1. All right, and so those are my values. X is equal to 1, y is equal to 1. So I'm going to write my solution as a coordinate point because that's what we're finding. All right, so we've got, solution is in the form of x, y. All right, plug those values in. So our solution then is just going to be the point 1, 1. And that's it. Okay, let's take a look at the next one. Now the next one, part B, we have 3x plus 3y is equal to 9. And then this bottom equation is solved for x. X is equal to negative y minus 3. All right, so the top equation is in standard form. The bottom equation is solved for one of my variables. So because this bottom equation is solved, I would use substitution in this case. All right, so what I'm going to do then is I know that x is equal to this whole thing. All right, that's the only one they give me. And so that's what I'm looking for. I'm looking for a variable that's solved for, one variable that's solved for itself. Okay, so now what I have, because x is equal to negative y minus 3, I'm going to rewrite my top equation. Okay, and I'm going to write 3 times x. So that's the first part. But I don't want to write x. I'm going to write what x is equal to, which is negative y minus 3. So I'm going to take this, I'm going to plug it in for x over here. And so I'm going to get this value of negative y minus 3, and then continue writing the equation. Plus 3y is equal to negative 9. So the question is, what's the difference between this top equation and this equation? And there's really no difference. Okay, the only difference is that I've replaced x with what x is equal to. All right, so now my entire equation contains only y's, and I can solve for y. So let's do this. Let's go ahead and distribute this 3 here, and we're going to multiply 3 by negative y and 3 times negative 3. So we're going to get negative 3y. Okay, 3 times negative y is negative 3y. 3 times negative 3 is negative 9, so minus 9, and then plus 3y, and that's equal to negative 9. Now here's where it gets a little weird. Okay, so I have negative 3y plus 3y on the same side of the equal sign. Okay, equal sign's over here. When I want to combine my like terms here, so negative 3y and positive 3y, those are going to add to 0. Okay, those are going to cancel out. All right, so then I have 0 minus 9 is equal to negative 9. So I get negative 9 is equal to negative 9. Now what I know about this, all right, negative 9 is equal to negative 9. This statement here is true. All right, so this is kind of one of those special examples when we solve systems of equations. So either you're going to get numbers, okay, or those variables are going to cancel out and you're going to get some sort of statement, whether it's true or not, true or false. In this case, this is true. So because this statement is true, what I can conclude from this is that I have infinite solutions. Okay? And when I have infinite solutions, that means that I have the same line. Okay? And that's what we're doing. All right, let's take a look at the next one. On this one, what I have 4x plus y is equal to negative 12, and I have 8x plus 2y is equal to 6. Now, what's going to happen here is, both of these equations are in standard form, meaning that x and y are on the same side of the equal sign. And I don't have in either of these equations, one of these equations solve for a variable. However, I have this single y here, and that's what I'm looking for. Okay, in this example, I can solve this equation for y. So if I rewrite this equation over here, 4x plus y is equal to negative 12. I'm going to go ahead and subtract 4x from both sides. Okay, and so I get that y is equal to negative 4x minus 12. All right, and that's good. So once I solve for y, what I can do is I can take the value, what y is equal to, and substitute it into my other equation for y. So I'm going to do this. I'm going to rewrite this as 8x plus 2 times y. Well, y is equal to negative 4x minus 12. So I'm going to rewrite that as negative 4x minus 12. And then that's all equal to 6. Okay, so let's go ahead and distribute my 2 here and solve this equation for x. And so on the left side, I get 8x plus 2 times negative 4 is going to give me negative 8. So I get negative 8x. 2 times negative 12 is going to give me negative 24. Okay, and that's going to be equal to 6. Now, here's the unique thing. I get 8x plus negative 8x. Those are going to cancel out and give me 0. So I have 0 minus 24 is equal to 6. Okay, 0 minus 24 is just negative 24, and that's equal to 6. Now you have to analyze this statement. This statement right here was false. Okay, 6 is not equal to negative 24. Okay, this is a false statement. So because I have a false statement, what that means, the conclusion that we must draw is that this is has no solution. Okay, and so because I have no solution, these lines are parallel. All right. So what you have, guys, is that you have this concept of either you're going to get a solution, okay, with numbers, or you're going to get a true statement, which means you have infinite solutions. Either you're going to get a false statement, meaning you have no solution and that the lines are parallel. Okay, so you're going to have these three options here. All right, so now let's go ahead and, this is the substitution method. Let's go ahead and look at the elimination method. Okay, so what they do is they call this the addition method. Okay, I call it the elimination method, so let's go ahead and rewrite that as elimination. All right, elimination. And there's a reason why we call it the elimination method. And what we're going to do is we're going to try and eliminate the x's and y's. And we have the same systems of equations, so we're going to get the same answers that we had gotten before. But what this is going to do is allow us to kind of show you a different method to solve the same equation. Okay, so on this one, what we want to do is we want to make sure that our variables are lined up, that the y's are on top of each other and that the x's are on top of each other. And what I'm going to do, I want to get opposite coefficients. Now the coefficient is the number in front of the variable. Now because I have a 1 here in front of the y, this is really just a 1 times y and a 1 times y. Because I have a 1 here, I'm going to eliminate the y value. Okay? Now what I want though is opposite y values. So I'm going to do this. I'm going to multiply one of these equations by negative 1. Okay? And I have to distribute that into everything. Okay? So I'm going to first rewrite my top equation as 1y is equal to negative 2x plus 3. All right. Now, once I multiply this bottom equation by negative 1, I get negative 1 times 1y, which gives me negative 1y. And that's equal to negative 3x. Okay, negative 1 times 3x gives me negative 3x. Negative 1 times negative 2 is going to give me positive 2. Okay, and then what I do is I just add them together and I add the columns. Okay, so if I take 1y plus negative 1y, that's going to cancel out and I'm going to eliminate the y, hence the name elimination. So I'm going to get 0 over here. I've eliminated the y value. I'm going to take negative 2x plus negative 3x, which gives me a total of negative 5x. And then 3 plus 2, which is going to give me 5. Okay, and so what I've got with this, now I have this equation that's completely solved that only has an x in it. I've eliminated the y. So now what I can do, I want to solve this for x. You can do this a number of ways. But what I want to do is I'm going to go ahead and add 5x to both sides. Okay, so this cancels out over here. I get 0 plus 5x, which is just going to give me 5x. And that's equal to 5. Okay, and then what I'm going to do is I'm going to divide both sides by 5, and the 5 is going to divide out here, and 5 over 5 is going to give me 1, so 1 is equal to x. Okay, so now what I want to do is I want to take this value, I want to plug it back into one of my equations. I'll plug it into the bottom one. Actually, let's plug it into the top one. Okay, it doesn't matter which one we do. So I'm going to go ahead and do that. I'm going to do y is equal to negative 2x. X is equal to 1, plug that in, plus 3. So I get y is equal to negative 2 plus 3. Negative 2 plus 3 is going to give me 1. So it's the same thing that we got. So you should understand that, you know, these are the same systems of equations. We're going to get the same thing, but you can do it doing two different methods. Okay, so this is going to be 1, 1 as my solution. Okay, over here, you know, on this equation, I've got 3x plus 3y is equal to negative 9. and I've got x equals negative y minus 3. Now what I want to do is I want to line up my x's and y's. So I'm going to rewrite my top equation over here, and I'm going to do 3x plus 3y is equal to negative 9. And on the bottom side, what I want to do is I want to move this y value over to the other side so that I have x and y on the left side of the equal sign, just like this one does. Okay? And so I'm going to go ahead and add a y value to both sides, add a y, and this is going to give me x plus y is equal to negative 3. Now what you notice here is that I have my x's are lined up and my y's are lined up. Now what I want to do, and it doesn't matter which one you eliminate, you can choose to eliminate the x or the y. What I want to do is I want to get opposite coefficients here. So let's go ahead and let's eliminate the y value. I kind of just like that. X is my favorite variable. So I choose to do that. So I'm going to multiply this bottom equation by a negative 3. Because I want to, my goal is to take 3 and add a negative 3 to this so that they'll cancel out. So let's distribute this negative 3 here into each of these. And so then my next step, okay, let's rewrite all of this. I've got 3x plus 3y is equal to negative 9. I've got negative 3x plus negative 3y, and that's going to be equal to positive 9. So let's go ahead and just add these together. Now what you notice is that all these are opposites, all right? And that's kind of a nice thing, because when I take 3x plus negative 3x, that's going to cancel out to 0. Okay, when I add 3y plus negative 3y, those are also going to cancel out and give me 0. And then negative 9 plus 9 is also going to cancel out and give me 0. So we get 0 is equal to 0. And what we end up with is a true statement. All right? So this is a true statement, and so that tells me that we have an infinite number of solutions. Okay? And that's it. All right. Let's take a look at the next one. On part C, and what I have is I have 4x plus y is equal to negative 12. I've got 8x plus 2y is equal to 6. Okay, both of these are in standard form. That's nice. Usually that's kind of where I choose to do elimination, is when both equations are in standard form. All right, when they're already lined up, that kind of just tells me, all right, let's just do elimination. It's just less work that I have to do. So I'll eliminate the y because I don't really like y. I prefer the x value. And I have a 2 down here, and I have a 1 here. So what I want to do is I want to multiply this top equation by negative 2 to eliminate the y. Okay, so I'm going to distribute that negative 2 into each of these. All right, and so let's rewrite this over here. I'm going to get negative 8x. Okay, and I got that because I did negative 2 times 4x, negative 8x. Negative 2 times y gives me plus negative 2y. And then negative 2 times negative 12 gives me positive 24. Okay? Now, I'm just going to keep the bottom equation the same, and that's going to be positive 8x plus 2y, and that's going to equal 6. So if I add these together, what's going to happen is that my x's and y's are both going to cancel out. Okay? And the reason is because they're opposites. Negative 8x plus 8x cancels out to 0. Negative 2y plus 2y cancels out to 0. And then I get 34 is equal plus 6, which is going to equal 30. So I get the statement that 0 is equal to 30. And this is a false statement. Okay, these two numbers are not equivalent. So because that's a false statement, what I want to do is write that we have no solution. All right? So pretty self-explanatory. Hopefully you've seen this before. But go ahead and get the homework started, and we'll look forward to the next video. See you in a bit. Thanks. Bye.